belongs to class 10 NCERT syllabus. Probably you all should know about that. So, we are starting with acid, right? So, what is acid? Let's describe acid through some basic properties. Acid is kind of substance which is sour in taste. It turns blue, litmus to red. According to Arrhenius theory, it will release H plus ion in aqueous solution. Its aqueous solution conducts electricity. So these four are basic features that you have read in the book, but we have to understand that. Look, sour in taste or turn blue litmus to red. These are basically physical properties kind of thing. But you have to realize is Arrhenius theory, and that depicts it will release H plus ions in aqueous solution. So what does it mean? If suppose we take hydrochloric acid for our reference and we take HCl in aqueous solution, it will be divided into two parts, right? Rather it will be ionized into two parts. One is H plus and another is Cl minus. So these properties are very same for all the acids. If you take any acid, it will release H plus ion in its aqueous solution, right? So that is very important part that Arrhenius has already depicted, right? So types of acid according to their source. So first we should concentrate on natural acid. Now the second part is mineral acid. So from name it is pretty clear that what the properties that natural acid has. So these acids are found from natural source, obviously. Acetic acid, methanoic acid, citric acid, these have the sources that resides in nature, right? So these are called natural acid. And for mineral acid as well, you can see these acids are prepared from minerals. These are called synthetic acid. Hydrochloric acid, sulfuric acid, nitric acid, etc. These acids can be produced in the lab, right? So here I have given some examples like acid and their sources. This might be important for your exam point of view. So ascorbic acid, can you tell me the source? Guava. Acetic acid, can you tell me the source? Vinegar, right? Citric acid, lemon, orange, etc. Lactic acid, curd, dahi, we should know. Tartaric acid, tamarind, and methanoic acid, and string, etc. So these are the examples of acids and their sources. Now I am coming to the part of strong acid and weak acid, right? Strong acid gets completely ionized in aqueous solution and thus produces large number of H plus ions. It has low pH level. Now why it has low pH level we will see later, but strong acid means more number of H plus ions in their aqueous solution. Hydrochloric acid HCl, nitric acid HNO3, sulfuric acid H2SO4, these are the example of strong acid. And for weak acid we can see it gets partially ionized in aqueous solution and thus produces less number of H plus ion. So for weak acid we can see it has low number of H plus ions. It has high pH level. Again we will see it later. So we can see CH3COOH, carbonic acid H2CO3. These are example of weak acid because they produce very less number of H plus ions in their aqueous solution. So it is all about H plus ions or the number of H plus ions. This is how we differentiate between strong acid and weak acid, right? Now we are coming to base. So what is base? Again we are trying to understand base through its properties. It is bitter in taste, turned red litmus to blue. Again, according to Arrhenius theory, it will release OH minus ions in their aqueous solution. It is very important. For acid it was H plus ions, for base it is OH minus ions. Bases are soapy in touch, like soap itself is a base, right? So again we are coming to the part of strong base and weak base. Look, the analogy is same. What we learned when we were going through strong acid and weak acid. Strong acid means higher number of H plus ions, because H plus ions identify acid, right? So for strong base, large number of OH minus ions, because OH minus ion identifies base. Strong base get completely ionized in their aqueous solution and thus produces large numbers of OH minus ion like sodium hydroxide, NaOH, right? And for weak base we can see it gets partially ionized just like weak acids in aqueous solution and thus produces less number of OH minus ion, ammonium hydroxide. This might be an example of weak base NH4OH, and NOOH or sodium hydroxide, this might be an example of strong base. Now further we can differentiate bases into two more categories. One is water soluble and another is water insoluble. Water soluble base means these bases are soluble in water. So these bases are known as alkali, sodium hydroxide, potassium hydroxide. And second we can see water insoluble base, copper oxide CO, lead oxide PbO, magnesium oxide MgO. They are water insoluble oxides or base. Now from there an important conception raises, that is, you can see here, if a base is water soluble it is called alkali. So all alkali are bases, but all bases are not alkali. This is a very popular question, and when I put questions for my student, then I used to ask these questions for several times, that what is the difference between base and alkali, or depict the term that all alkalis are base but all bases are not alkali. The answer is alkali is kind of bases which are water soluble. So all alkalis should be base, has to be base. But all bases are not alkali because all bases are not soluble in water. There are bases which are not soluble in water, like copper oxide, like lead oxide. So these are not alkali, right? So this is the difference. Now I am coming to the next part, that is indicator. What is an indicator? An indicator is a substance that indicates the acid or base nature of a solution by changing its color or smell. From name it is pretty clear. What is indicator? That indicates something. What does it indicate? It indicates whether a substance, whether a solution is acidic or basic by changing its color or smell. That is what indicator does, and that is how it is relevant to our study, right? Types of indicator. So there are natural indicators, there are olfactory indicators, there are synthetic indicators. So you can see, like, natural indicators means they are obtained from natural resources like litmus. Olfactory means that change smell in acidic solution or basic solution like onion. And synthetic means that can be produced in lab like phenolphthalein or methyl orange. So these are three types of indicators that we can see. Please note it down. Now, behavior of different indicators. How indicators indicate that the solution is acidic or basic, right? So acid plus blue litmus becomes red. Base plus red litmus becomes blue. We have seen these both cases when we are going through acid and base, right? Now if we put phenolphthalein into acid, acid plus phenolphthalein, it will go colorless, because the original color of phenolphthalein is colorless and it retain its color in acid. But if you put phenolphthalein in base, then the solution becomes pink. So this is how we can determine that whether it is acid or base. Methyl orange has original color orange, is pretty clear from its name. When you put acid in methyl orange, it becomes red. When you put base in methyl orange, it becomes yellow. So that is the difference. Now, acid plus juice of red cabbage is reddish. Means if we put juice of red cabbage into acid, it becomes reddish. The original color of juice of red cabbage is purple. So we can easily determine whether it is acidic or not. And if we put base in juice of red cabbage, it becomes greenish. So from this color change we can easily determine whether it is acid or base. Same goes to turmeric. Acid plus turmeric becomes yellow, and turmeric becomes reddish brown if we put base into turmeric. And last one, the only one which one is olfactory kind of indicators, that is onion. If we put acid into onion, it does not change its smell. Onion retains a smell, but if we put base into onion, the smell vanishes. So this is a popular way to determine the solution is acidic or basic. Just put onion on that and try to find out the smell. If smell retains, it means acid. If smell vanishes, it means base. Now I am coming to the next part. It's very important part, pH. I have seen lots of students, even when they are in class 12, they have some difficulties to understand pH. What is pH? pH is nothing. It is a measure of how acidic or basic a solution is. It ranges between 0 to 14. So far we have understood acid, we have understood base, we have understood the basic properties of acid and base. We have determined how to use indicators to identify whether a solution is acidic or basic. Now the next part is that we have to measure how acidic or basic a solution is. It is defined by a formula. pH equals to minus log base 10 H plus, right? pH equals to minus log base 10 H plus. So basically it measures the concentration of H plus. If we understand logarithm, you will find that here the pH parameter and H plus is sharing an inversely proportional relationship. So it is clear, if H plus increases, pH level decreases. So H plus, the concentration of H plus ion and the reading at pH scale is inversely proportional. Here we can see, if we increase H plus ion, the concentration of H plus ion, the pH level drops. So it is pretty clear from this equation. So for acid, pH level obviously less than 7. For water, it is equals to 7, and for base it is greater than 7. You have to remember this. You have to understand the scale. If there is an acidic solution, pH level less than 7, if pH level merges to 0, that means it is getting more strong acid, because we have said that if the concentration of H plus ion gets increased, the pH level drops. So pH level can be minimum at 0. So at 0 we can get the most strong acid. But if pH equals to 7 or close to 7, that means the acid is weak. Similarly, if pH equals to 7, it means it is weak base or weak alkali. If pH equals to 14, that means strong alkali. You have to understand that. There are few examples of pH in different scale. pH in digestive system, we need hydrochloric acid for digestion. So it is evident that our digestive system will have pH less than 7. Mostly it is minus 1.5 to minus 3.5. pH in soil, it is close to 7 because it can be neither acidic or nor highly alkaline, because this balance is helpful for plants as well. Plants take food or things from soil, so pH in soil is close to 7, like it stands on neutralization level. Now tooth decay, if pH in the tooth is less than 5.5, tooth decay starts. When we have a tooth decay, you have to realize that the acidic part in your tooth is getting increased, so you have to neutralize it. So which can neutralize the acidic effect? It is alkaline or base. We need alkaline to resist this kind of paste we do use for clearing the tooth is alkaline or is basic in nature, right? Now I am coming to salt. What is salt? Salts are ionic compounds. Those are produced after the reaction between an acid and a base. So there will be an acid, there will be a base, they will get reacted and salts will be produced. Simple. There are different properties of salt, that is why I had to use different colors so that you can get it easily. Most of the salts have a crystalline structure. Take NaCl, sodium chloride. It has a crystalline structure. Okay. Salts can be colored or colorless. Salts can be opaque or transparent. Most of the salts are soluble in water. Aqueous state of salts conduct electricity, but salts in normal state are electrically neutralized. These are very few basic of salts that you have to memorize. Now type of salts. There are three types of salts we can see. First is neutral salt, second is basic salt, and the third one is acidic salt, as you can see here. Now what is neutral salt and what is acidic salt or what is basic salts? In order to understand this, we have to go through a basic understanding. If we put strong base and strong acid and they react, natural salt will be produced. So strong base will have to react with strong acid. So natural salt and water will be produced. Take an example of strong base, sodium hydroxide, strong acid, HCl. They will have a reaction. So sodium chloride will be produced and water. So here we can see sodium chloride is neutral salt. So it is neither acidic nor basic. It is neutral. So we need strong base and strong acid in order to get natural salt. And as we can see that natural salt will have a pH equals to 7. So it is good for health. pH equals to 7. Now I am coming to acidic salt. Can you tell me which kind of combination will be allowed here? Acidic means the acid portion will be greater. So strong acid will have to react with weak base. So weak base will have to react with strong acid. We will have acidic salt and water. Weak base means NH4OH, ammonium hydroxide. We all know it is weak base. Strong acid HCl, fine. NH4Cl, ammonium chloride. So NH4Cl becomes acidic salt and water H2O, right? As it is acidic, the pH level should be less than 7. And for basic salts, if you understood the previous two slides, you will have to understand this slide. You will yourself understand what I want to mean in the slide. So basic salt means strong base. Basic base portion will be higher. Weak acid, basic salt and water. 2NOH, sodium hydroxide, we all know it is a strong base. Weak acid, carbonic acid, H2CO3. Basic salt, NO2CO3 and water, H2O. So these are three types of salts: neutral, acidic and basic. Probably we have understood. As it is basic, it will follow the pH level of base, so pH should be greater than 7. Now reaction of acid. Metal plus acid will produce salt and hydrogen. Take an example. Zinc is a metal, acid means ACl, okay. We are having ZnCl2, zinc chloride and hydrogen, right? So zinc plus hydrochloric acid produces zinc chloride and hydrogen. This example is very important because this is an identification process of H2. This is used to test hydrogen gas. If you bring a lighted candle to the gas produced after acid and metal reaction, the gas burns with a pop sound. This is the identification process of hydrogen gas. So this reaction is used to identify hydrogen. Okay, this is an identification process of hydrogen, and the equation is important because this is how a metal react with an acid. Second part is metal carbonate plus acid will produce salt, carbon dioxide and water. This is also very important. Metal carbonate, take Na2CO3 for reference, acid HCl, it will produce sodium chloride, salt, carbon dioxide and water. So here sodium carbonate plus hydrochloric acid produces sodium chloride, carbon dioxide and water, right? Now there is another extension. If we have a reaction between sodium bicarbonate or bicarbonate salt and acid like H2SO4, it will produce Na2SO4 salt, carbon dioxide and H2O. So these equations might be important for your exam. Uh, if you are doing the class of WG, you will get lots of questions on that, and probably you have already got the solution, right? So it is very important from exam point of view. So here I have given the name for your ease, so you can see it here. Now reaction of base, metal plus base, again salt plus hydrogen. So zinc and base is sodium hydroxide NaOH. What will be produced? Na2ZNO2 and hydrogen, right? So Na2ZNO2 basically is a salt. So zinc plus sodium hydroxide will get sodium zincate. Na2ZNO2 means sodium zincate and hydrogen. Non-metal oxide plus base, it will produce salt, water. So non-metal oxide means CO2, carbon is non-metal, so CO2 is non-metal oxide. Take any base, 2NaOH, sodium hydroxide we have taken for example or reference. So you will get Na2CO3, sodium carbonate, that is a salt, and water we will have. So here you can see non-metal oxide is acidic in nature. We know acid and base reaction produce salt and water. So this is kind of acid plus base reaction because CO2 is non-metal oxide and non-metal oxide is basically acidic in nature, and sodium hydroxide we know it is a base alkali, so it will obviously produce salt and water. The next part is aqua regia. This is very important question, so we have to understand that this is a mixture of hydrochloric acid and nitric acid. It is yellow orange fuming liquid that can dissolve gold and platinum, right? So 3HCl plus HNO3. This mixture is called aqua regia. We'll have nitrosyl chloride NOCl, water and chlorine. Further, NOCl, it is very volatile in nature. It gets disassociated to 2NO and Cl2, right? And then we can see nitric oxide and chlorine will be produced from NOCl. So 2NO will react with oxygen and it will produce 2NO2. Aqua regia is used to electrolyte for refining the gold. It is very important part of this whole acid and base chapter. So these are the basic concepts of acid, base and salt. I have deliberately avoided a part, that is production of baking soda, bleaching powder, etc., etc., because there are nothing to understand in those part. Just you have to realize that you have to mug things up, you have to write down the formulas. So I will give you this part as a note, so I think that will be helpful for you. So I think you have understood the basic conception of acid, base and salt. If you have any doubt, don't forget to mention in the message. I will read individual messages and I will try to solve individual problems. though it will take more time, but I'll try to solve, right? So thank you for attending this class. So this is a thank you message from me. Thank you.